Good afternoon, everyone, and welcome. Today, we're going to dive into the fascinating world of the scientific method and research within the behavioral sciences. We'll explore everything from how to form a solid hypothesis to diving into advanced data analysis techniques, all while keeping ethical considerations firmly in mind. I'm excited to take you through this journey of discovery and understanding in behavioral research. Let's get started. The scientific method is essentially a structured way to gain knowledge by posing precise questions and then seeking well-founded answers. It's more than just one approach. It combines various ways we typically try to understand the world, like rely on tradition, our gut feelings, trusted experts, logical reasoning, and direct observation. Each of these methods on its own has its weaknesses. So by integrating them, the scientific method helps us overcome those limitations. This integrated approach ensures that the answers we get are not just guesses, but are accurate, dependable, based on evidence, unbiased, and open for others to verify. Importantly, this method is fundamental not only in behavioral sciences, but also in a wide range of scientific fields where understanding complex phenomena is crucial. Ultimately, the answers it produces stand out because they meet these core standards of reliability and objectivity. The scientific method follows 5 key steps that help us explore and understand phenomena in a structured way. First, observation involves noticing and identifying behaviors or events that catch our attention. Next, based on these observations, we form a hypothesis, a tentative explanation that we can test. From this hypothesis, we make predictions, which are specific statements about what we expect to happen if our hypothesis is correct. Then comes systematic observation, where we carefully plan and conduct experiments or gather data to test these predictions. Finally, we analyze our results to draw conclusions, which might support our original hypothesis, require us to refine it, or even reject it altogether. This process ensures that our understanding is grounded in evidence. Every research journey begins with a spark, a question or idea about how 2 or more variables might be connected. This initial curiosity is what drives us to dig deeper. From there, we formulate a hypothesis, which is essentially a testable prediction based on that question. For example, if we ask whether using visual images influences memory, our hypothesis might be that using these images leads to better memory performance. This hypothesis isn't just a guess. It actually shapes the entire study. It guides how we design our experiments, determine what data to collect, and how we analyze the results to see if our prediction holds true or not. It's a foundation that directs the whole research process. When considering the characteristics of a good hypothesis, the first important aspect is that it must be logical. This means it should be grounded in existing theories or supported by prior research findings, ensuring it makes sense within the context of what is already known. Next, a good hypothesis needs to be testable. This requires that the variables involved can be observed and measured in a practical way, allowing us to gather data for analysis. The third characteristic is that the hypothesis must be refutable. In other words, there should be a possibility to disprove it through empirical evidence if it turns out to be false. Lastly, a good hypothesis is positive. It clearly states an affirmative relationship or effect, rather than being vague or ambiguous. These 4 steps help ensure that our hypothesis is both meaningful and scientifically sound. When we talk about testable hypotheses, we're referring to ideas that involve variables we can observe or measure. This means we can gather data and evaluate whether our hypothesis holds true or not. It's essential because if we can't test something, we can't really know if it's accurate. Now, refutable hypotheses are equally important since they allow us to prove them false. This ability is what gives scientific research its strength and credibility. If a hypothesis can't be shown wrong under certain conditions, it doesn't help us move forward in understanding. To highlight this, consider some examples of non-testable hypotheses. One is a statement: the more sins a man commits, the less likely he is to get into heaven. There's no way to observe or measure this reliably, so it isn't testable. Another example is, if old dogs could talk. This is purely hypothetical and can't be tested since it's based on an unreal condition. Lastly, take the claim that the human mind emits unmeasurable thought waves. Since these thought waves cannot be detected or measured, This idea cannot be proven or disproven scientifically. All these illustrate why hypotheses need to be both testable and refutable to serve as a solid foundation for valid scientific research. To ensure quality in scientific research, we start by applying the scientific method along with strict hypothesis standards. This combination is essential because it helps produce research that is both credible and of high quality. Next, researchers focus on collecting evidence systematically and objectively. This means carefully gathering empirical data while working hard to minimize any bias that could influence the results. Finally, fostering transparency and replicability is crucial. By making methods and results publicly available, other scientists can review, replicate, or challenge the findings. This openness is what drives the advancement of reliable knowledge, especially in behavioral sciences, as it allows hypotheses and theories to be continually refined and improved. When turning a hypothesis into a research study, we need to be clear about what exactly we're measuring and how. This means operationalizing the variables so that abstract ideas become concrete and measurable. We also have to define who our participants will be and carefully plan how we will collect the data. For example, one study might look at college students and test the hypothesis that those who use mental imagery while studying will recall more words than those who don't. Another study could focus on 10-year-old children, comparing recall between those who see pictures and those who see word lists. These examples show how different participant groups and methods help us examine the same hypothesis from various angles. By varying these elements, researchers can gather stronger, more comprehensive evidence. So, the key steps in study planning are operationalizing variables, defining your participants, and designing how you will collect the data. Each of these is essential to turning a broad idea into a valid, testable study. Let's look at how to evaluate questions and hypotheses in scientific research. First, when identifying appropriate scientific questions, we need to avoid questions that can't be tested, like how many angels can stand on a head of pin, or moral questions such as is abortion moral or immoral? These don't fit scientific inquiry. Then, we move to recognizing suitable scientific questions. For example, what conditions promote student learning in an elementary classroom? This is a great question because it can be tested and observed. Next, some questions lie outside the scientific method, like imagining, how would life be different if computers had never been invented? This is more speculative than testable. When it comes to good research hypotheses, these should be clear and testable predictions, such as increased sugar consumption leads to increased activity, or smaller class size relates to better academic performance, and even self-esteem relates to persistence at tasks. These hypotheses set a basis for investigation. On the other hand, poor hypotheses like stating no relationship between fatigue and reaction time are not good because they predict no effect, which makes testing less meaningful. Understanding these distinctions helps ensure research is focused and productive. When we talk about quantitative research, we're focusing on measuring variables in a way that produces numerical data. This data can then be analyzed statistically to give us clear answers about things like how much something occurs, how big a certain effect might be, or how strong the relationship is between variables. For example, we might measure adolescent depression by using standardized tests that assign a score, giving us concrete numbers to work with. On the other hand, qualitative research takes a different approach. Instead of numbers, it involves collecting detailed observations and creating narrative reports that help us understand and interpret behaviors or phenomena. This often means conducting interviews and then looking for common themes or patterns in the responses. For instance, we might interview adolescents to explore their personal experiences with depression and then summarize the key themes that emerge from those conversations. Both methods offer valuable insights, but they do so in very different ways. One through numbers and statistical analysis, the other through rich, descriptive storytelling. When we look at the research process, it all starts with a general research idea. This initial idea sets a direction and helps focus the entire project. From there, researchers move on to planning how they will approach their study. This includes deciding what variables to measure and carefully collecting the data needed to answer their research questions. Once the data is gathered, the next crucial step is to analyze and interpret the results. This is where researchers make sense of the information, drawing conclusions and gaining insights that address the original questions. Each of these steps is essential for conducting thorough and meaningful research. The first step in developing a research project is to find a research idea. Start by choosing a general topic that interests you or is relevant to your field. This ensures you stay motivated and engaged throughout the process. Next, conduct a thorough literature search using databases like PSYC Info, especially if you're working in psychology. This helps you understand what research has already been done and where gaps exist. Finally, use what you find to narrow and refine your focus. This step is crucial because it allows you to pinpoint unanswered questions and transform your broad topic into a specific, researchable question. For example, broad topics might include obesity, human development, or perception, but you'll want to move towards something more targeted within those areas. After pinpointing a research question that looks at relationships between variables, the next step is to form a hypothesis. Think of a hypothesis as your best educated guess or tentative answer, based on what previous studies have shown or logical reasoning you've worked through. For example, you might hypothesize that a painful stimulus will feel less intense if a person is cursing compared to if they are not. This sets a clear expectation that you can then test through your research. Now, let's talk about the importance of defining and measuring variables carefully. First, we need to precisely define our variables. This means turning abstract concepts into something we can actually measure. For instance, in a study exploring swearing and pain, the idea of perceived intensity of pain is transformed into a measurable concept, like pain tolerance. To operationalize this, researchers might measure how long participants can keep their hands submerged in ice water. This concrete measurement makes the data reliable. Finally, having clear and consistent definitions for variables is crucial because it ensures that data collection is consistent and the analysis is meaningful. Without this clarity, our results could be misleading or hard to interpret. When identifying participants, it's important to choose individuals who match the specific criteria relevant to your study's goals, such as age or demographic factors. Next, determining the right sample size is crucial to ensure your results can be generalized and that your study has enough statistical power to detect meaningful effects. Equally important is developing a thorough ethical plan. This includes securing informed consent, maintaining confidentiality, and minimizing any potential harm to participants. Finally, promoting ethics throughout the research process not only protects participants, but also builds trust and supports the overall integrity of your study. When selecting a research strategy, it's important to find the right balance between internal and external validity to properly investigate your hypothesis. One option is the experimental strategy, where you manipulate variables to establish clear cause and effect relationships. Another approach is a descriptive strategy, which focuses on observing and recording characteristics or behaviors without influencing them. Then there's a correlational strategy, which looks at relationships between variables but doesn't involve any manipulation. Finally, we have non-experimental and quasi-experimental strategies. Non-experimental methods involve observing variables as they naturally occur, while quasi-experimental designs apply experimental techniques, but without full randomization. The choice you make here is crucial, as it shapes how you design your study and interpret your findings. Now, let's talk about choosing a research design. First, we have the between-subject design, where different participants are assigned to separate groups, allowing us to compare outcomes across those groups. Next is the within-subject design, where the same participants go through multiple conditions, letting us observe changes within the same individuals. Then there's a factorial design, which studies two or more variables at the same time, helping us understand how they might interact. Finally, the single case design focuses on intensive observation of just one participant or a small group, providing detailed insights on individual cases. Each design has its strengths, so selecting the right one depends on the goals of your study. Now, moving on to steps 7 through 10, which focus on conducting the study and refining your idea. Step 7 is where you collect your data according to the design and ethical guidelines you previously established. It's crucial to stay disciplined here to ensure the integrity of your data. Next, in step 8, you'll evaluate the data using appropriate statistical methods. This analysis helps you accurately interpret the results and draw meaningful conclusions. In step 9, you'll report your findings transparently and ethically, making sure to present your results clearly and honestly. Finally, step 10 involves using these findings to refine or even reformulate your hypotheses or develop new research questions. This iterative process is essential because it drives scientific progress forward, allowing each study to build on the last. When it comes to using AI in the research process, there are several key areas where it offers significant advantages. First, AI can streamline literature searches by quickly scanning through vast academic databases to find the most relevant studies, saving researchers a lot of time. Next is data collection, where AI helps automate the gathering of information, whether from experimental results or various online sources, ensuring efficiency and accuracy. In data analysis, AI applies advanced algorithms to complex datasets, helping detect patterns that might not be immediately obvious. Another exciting application is hypothesis generation, where AI can suggest new and innovative hypotheses based on the information it processes. Finally, AI plays a valuable role in reporting by assisting researchers in summarizing their findings clearly and creating visualizations that make the data easier to understand. All of these steps illustrate how AI can be a powerful partner throughout the entire research journey. The scientific method isn't just a straightforward checklist. It's an ongoing, iterative process. Researchers don't simply move from one step to the next and stop. Instead, they continuously revisit and refine their questions and hypotheses. This means they often go back to earlier stages, tweaking their methods to improve accuracy and reliability. Because of this cyclical nature, scientific knowledge is always evolving. New evidence and perspectives drive researchers to reconsider previous conclusions, leading to a deeper and more nuanced understanding over time. This dynamic process is what allows science to progress and adapt as we learn more. When conducting research, we often face several common challenges that can impact the quality and reliability of our findings. First, bias is a major concern. It's crucial to recognize and minimize any personal or procedural influences that could skew the results. Next, we have ethical concerns. Protecting the welfare and rights of participants is not just a requirement, but a fundamental part of responsible research. Another challenge is controlling variables. To establish valid relationships, we need to isolate factors carefully and ensure that other influences don't interfere with our data. Finally, maintaining objectivity is essential. We must evaluate data impartially, resisting any expectations or preconceived notions that might affect how we interpret results. Addressing these challenges thoughtfully helps us produce trustworthy and meaningful research. Ethics play a crucial role in research by protecting both the participants and the overall integrity of the study. One of the most important aspects is obtaining informed consent, which means making sure participants fully understand what the research involves and agree to take part voluntarily. Maintaining confidentiality is another key principle. It helps protect the privacy of participants and keeps their data secure. Researchers must also avoid causing harm, which involves carefully designing studies and monitoring for any negative effects as the research progresses. Finally, ensuring compliance with ethical guidelines and having oversight from institutional review boards helps guarantee that the research is conducted responsibly and ethically throughout the entire process. Peer review is an essential step in maintaining quality in scientific research. It involves independent experts carefully evaluating a study's design, methodology, data analysis, and conclusions before the work is published. This thorough evaluation helps validate the research, making sure the findings are reliable and meet high scientific standards. Additionally, peer review plays a crucial role in identifying any errors, biases, or ethical concerns that might be present, which ultimately improves the overall quality of the research. By going through this rigorous process, we build trust in the published results, both within the scientific community and among the public. Research is evolving at an unprecedented pace, driven by technological advances and increased collaboration across disciplines. One of the most exciting developments is the growing role of artificial intelligence. AI tools allow us to analyze data more efficiently, recognize complex patterns, and even generate new hypotheses that might have gone unnoticed otherwise. This kind of interdisciplinary integration not only sparks innovation, but also broadens the perspectives we bring to scientific problems. As a result, we can expect faster discoveries, improved accuracy, and groundbreaking insights across fields. To keep up, it's crucial that we continue adapting to these new methods, as they will fundamentally shape the future of how we conduct scientific inquiry. In psychology and behavioral health, applying the scientific method is essential for advancing our understanding. It starts with systematic observation, where researchers carefully notice and document phenomena related to mental processes and behavior. From these observations, they develop hypotheses, educated guesses that offer possible explanations about disorders, treatment effects, or behavioral patterns. Next, these hypotheses undergo empirical testing through experiments or further observations, allowing researchers to evaluate them objectively and gather reliable data. This rigorous process is crucial because it ensures that findings are valid, ethical, and have real-world impact. Ultimately, this method helps improve mental health care and informs policy decisions. We see the scientific method applied across many areas, such as diagnosing mental illnesses, assessing therapy outcomes, conducting cognitive studies, and researching social behavior. Each of these benefits from a structured, evidence-based approach that advances both knowledge and practice. Psychological research starts by investigating key mental processes like perception, cognition, emotion, and behavior through carefully designed studies. From there, researchers develop hypotheses to explore specific questions. For example, how memory might be improved or the ways stress impact performance. To test these ideas, experimental methods are used to measure behavioral and cognitive variables, allowing for the collection of precise data. This evidence-based approach helps us draw valid conclusions about various psychological phenomena. Ultimately, these findings inform clinical practices, educational strategies, and intervention programs that are tailored to meet the needs of diverse populations. Behavioral health research centers on understanding the various factors that influence health behaviors and outcomes, such as addiction and lifestyle changes. Researchers collect data through surveys, direct observations, and controlled experiments, each providing unique and valuable information. This data is then analyzed statistically to identify important trends, correlations, and sometimes even causal relationships. The insights gained from this analysis help shape effective interventions, therapies, and public health policies. Ultimately, the goal is to improve mental health and well-being across different communities. Thank you for your attention, and I hope this overview has given you a clear understanding of how behavioral health research plays a vital role in supporting healthier lives.